Okay, so, oh my god, this is very loud. Okay, so I'm back from vacation, and let's just solve a graph problem, because graph problems are my favorite. There's an undirected weighted connected graph. You are given a positive integer n, which denotes that the graph has n nodes, labeled from 1 to n. An array edges where each edge's I is equal to u of I, v of I, weight of I. Oh, where each edge's I denotes that there's an edge between nodes u of I and v of I with a weight equal to weight of I. And it's undirected. Alright. A path from node start to node n is a sequence of nodes z of 0 to z of k, such that z of 0 is the start and z of k is the end. And there's an edge between z of I and z of I plus 1, where 0 is less than or equal to I, which is less than or equal to k minus 1. Gotcha. The distance of a path is the sum of the... This is too intense music. Wait, I want to try this one. This one. There we go. The distance of a path is the sum of denotes the shortest path, distance of a path between node n and node x. A restricted path is a path that also satisfies that distance to node z of I is greater than distance to less node z of I plus 1. Return the number of restricted paths from node 1 to node n. Since that number may be too large, return it modulo 10 to the 9 plus 7. Okay, so let's just say int mod is equal to 1, 2, 3, 4, 5, 6, 7. Gotcha. And because of that, a lot of DP problems involve modulo because of the number of things you have to compute. So I'm suspecting a little DP play. I don't know why I said that. Return the number of restricted paths from a restricted path such that the distance. Okay, so with this example, I'm trying to get to 1 here to 5, and each circle contains a number in black and its distance to last node value in blue. The 3 restricted paths are 1 to 2 to 3 to 5, because the shortest path would be what, 4, right? Because this would be, okay, this would be 12. So yeah, the shortest path seems to be 1, 3, wait. No, it's not. Oh, wait. What the fuck? I'm blue. What the fuck are you talking about? Wait. Denote the shortest distance of a path between node n, and node x. Oh. Okay. That doesn't make it. Oh, because the closest to. Okay, yeah, the shortest path from here to here is 4. This is 0. This would be 2, 3. What? Oh, 2, 5, 6. Gotcha. That's what that's saying. So, a restricted path is a path that satisfies that distance to the Neely? This problem sounds like bot, dude. Okay. Where I is less than or equal to k minus 1. Cool, dude. I think just a good first step would just be constructing an adjacency. So let's just say int, a list of ints, adjacency to a new array list n plus 1, because we're starting from that. Int edge in edges, we could say that adjacency edge of 0 dot add new int edge 1 edge 2. Because this is undirected, we also need to flip around. There we go. So our adjacency list is constructed. A path from node start to node end is a sequence of, okay. Alright. And a restricted path is such that distance to z of I is greater than z of I plus 1. So the node before it? Okay. I don't know, a restricted path. I feel like they worded this really weirdly. I feel like there has to be a better way of explaining this to somebody. But I'm already spending a lot of time just kind of being confused, so now I need to lock in. What the hell is going on? 4, 6. Okay, so in this case, a restricted path is like from z to 1 is greater than that. Turn the number of restricted paths from node 1 to node n. So this is a restricted path because... What? Cool. So why is 145 not a restricted path? Because to 12. Because... Oh, because this to this? Is that why? Are you serious? So it's saying... So... If we start from here... A restricted path is a path that also z of I is greater than distance to that. Since this thing... So the shortest from here to here is less than... Wait, no. What is this problem trying to tell me? Dude. Wait. I'm really gonna spend 30 minutes reading this because I don't understand what's being told to me. There's an edge between z and z of I plus 1. Is it literally saying, like, this to this has to be greater than this to this? Is it just... What's up, dude? Great. It's the way they're phrasing it. It makes me want to think that like it's just every node that's not the shortest path, even though this is the shortest path and it's considered restricted. So where did K come from? Okay. So non-restricted passes 1. Okay. Great. Each circle contains a node number in black, and it's I feel like if I had an interviewer asking this, I'd need more clarification for sure. But I'm just an idiot. That z of I is greater than z of I plus 1. And there is an edge between z of I and z of I plus 1. So if I'm here at, let's just call this like I, so if I is equal to 1, cool. If I equals 1, distance to last node. Oh, I gotcha. And then when I'm here, oh, I think it makes sense, because here, this is greater than that, so I would not even continue on that path. So starting from 1. So I'd want to start from 1, but then how do I count all the paths that go... Ah! Wait, what is the space complexity? Because... Oh, okay. Nice. Right, because there's 1, 2 to 5. So it starts at 1 and then has to go to 5, but then how do I count the number of ways? If I go here, that is one path. I go here is one path, and here to here is one path. Do I need... Maybe I will start at 1, and then I'll traverse one path, right? And for every node after, like, let's say we just arbitrarily pick this one first. Every node after this, if this leads into that, I just kind of cache this because the number of paths from here to here that is restricted. DP something. How do I explain it? Okay. So, like, maybe I have Obsidian open, but I'll use Paint. So, if a node V is restricted, yeah, I'm gonna use Obsidian, bro. New node, new code. So if a node V from node U is restricted, then the number of restricted paths, restricted, and like V number of paths starting from V already computed, already computed, then number restricted paths at node U plus equal number paths at V. Because let's just say we picked traveling 1, so we have here, we go to here, so this is one path to 1 to 3, which is I don't know. Okay, wait. So at 3, there's only one path to 5 that is restricted. So I'd go here, I would cache like 1, I would memorize or whatever, 1 here. There's only one path. And then I'd go back here. Right, I go back here, I go to 2, then I go here. This node has already been visited. All the possible restricted paths have been added to this thing, so we'd also tack on all the right, and then okay, yay. So if we say int dp equal to new int n plus 1, where dp of I is equal to number of restricted paths from I to n. But does that mean we can just use a DFS? Like, I would think the move would be to, what would be the most optimal thing to do? The most optimal thing to do would be to prioritize, how long have I been sitting here? 17? Not too bad. Are there specific nodes I'd want to prioritize? How would I even, am I thinking about this backwards? So I'd start at 1, and I'd only traverse nodes where the weight, oh shoot, but I don't even know the shortest distance yet. That's the thing too. My thing doesn't know that yet, so I don't even want to do this one anymore. Because it seems really backwards to backwards to fill every shortest path, right? Unless I went backwards, no, that wouldn't work either. How do I, like, honestly, I could just try Dijkstraing every node to uh store the wait. I could Dijkstra's everything and then do another DFS. That sounds very expensive, especially with the time constraints. And Dijkstraing every node would be very expensive as well. Um, well, no, it wouldn't because I would just Dijkstra. Okay, so if I Dijkstra from 5 to every node, so int dist new int n plus 1, just store Dijkstras, yo, and then we just erase that fill dist integer.max value, and then we say dist of n is equal to 0. We say priority q. I think, let me see if I remember how to implement Dijkstra's from scratch. Where AB override A of 2 minus B of 2. And then PQ offer new int n 0, right? Okay. And while PQ dot is empty, we'll say int cur is equal to PQ dot poll. And I don't know. We could say if, oh, not that. If, just say like int u is equal to cur 0. Well, okay, whatever. Int weight is equal to cur 1. And if weight is greater than dist of u, we continue. I'm gonna just try to like remember how exactly I'll do this. But then for int v in adjacency u, if adjacency 1 plus w is less than dist v, then dist v is equal to that pq dot offer new int v dist v, right? And then let's just test that. Dist, gotcha. Oh, okay. I meant to do this. for int. That's wait. Why did I int edge if adjacency? Oh my god. Okay. Int v is equal to edge 0. Int w2 is equal to edge 1. If damn. Okay. Int v is equal to edge 0, and w2 is equal. So if w plus, oh wait, I don't need to do all that. Okay, I think that might work better. Oh, edge. Okay, for int I equal 1, I is less than equal to n, I plus plus adjacency, I is equal to new array lists. Right. Huh? What do you mean out of bounds for 2? What? Hey. Oh, not 2, it'd be 1. Duh. Okay, I don't know why that's that, but 1 is 4, this is 2, this is 1, this is 6, is oh right, because 0. Okay. Okay, and then this is 5, and then 6, and then 4, and then 7, and 3, and 2, and okay, so I remember how to do extras. Yay. Okay, now we just start from, so just store dextras, yo. Do a dextras and use that to DFS it, and by it I mean my graph. So is it DFS? Yeah, so we do a recursive backtracking DFS that uses just DP. Sounds really freaking annoying though. So oh man, this sounds really annoying. Okay, maybe I'll just, okay, I kind of want to just go on my phone and then come back to this later. How long have I been spending on this? 30 minutes. Oh. So how do we define our DFS? So like DFS at src u. Would we even need to return a value? Because probably not. src u. Oh, okay. Let's just code it. Public void, maybe int later. I don't know. DFS int u. List int AGSG int DP int Dist. Am I missing anything? Probably not. Oh, we should probably, do I need a set? Or can I use DP as a kind of makeshift set? How would I... Because there's a possibility that... Okay, let's just, there's a possibility that a node has 0. Okay, I'm gonna just assume 0. Assume 0 means unvisited, but if that breaks something, I will change. Lol. Okay. So, like if dp of u does not equal 0, return dp of u. Otherwise, so dp. Oh my god! Ah, why? All the way down. Okay, I'm gonna take a break, but then, how do you say? Then, I have the idea though. I just need to DFS and then just like if this thing is greater than this thing, then I can go to the path, and then if I reach this, I just count the number of. Okay, this is one path. There's another. I'll just count the number of paths. And then, ah, dude, yeah, I definitely need to make this thing in it, but I'll come back. I'll sleep on it. Wait. Okay, I am back. So, how are we gonna do this? How do you count paths again? Okay, let's just say like, So we could say if u is equal to dot length, right, minus 1, or n, then we can return 1, and then for int v, for int edge in adjacency u, what if we say let's just DFS from 1, adjacency dp dis dp1, right? Okay. And then we could say, let's return 0. And then we can say dp u plus equal DFS edge of 0. Oh, wait. Oh. So if dist of u is what, greater than? Yeah. Dist of edge, let's just say like v is equal to edge 0. Okay, uv voodoo. V, and then we'll start from v, adjacency dp dis. Modulo this, right? Does that even work? Watch it not work. Right, because... Duh. Oh, that's a good point, compiler. Why did I write that? Daily check-in. Oh, of course. Output 1. 1 is certainly better than Okay, so what am I... Honestly, I don't even know how to approach the DFS here. Oh, shoot. So if this thing is already solved, then return this. If that, return 1. DPU. I don't know. Hey, that, I know I didn't explain that at all, but that made more, okay, hopefully the time it doesn't time out. If it times out, I'm gonna, no, why? Is it because of the mod? I think it's because of the mod. Okay. ID sense. Like, how did, what the okay. Cool. I want to say it's the mod, because I would not want to be wrong. Because being wrong doesn't feel good. Man. Actually. Okay, hold up. I think I forgot how I'm supposed to... Am I modding it correctly? How would you return something modulo code? That's cheating. Should be that. Okay, that made that one wrong, so I'm not gonna do that. Oh, okay. So why is this wrong? I can't read that, by the way. What the fuck? One. Genuinely, what the fuck? What the fuck? This does not support visualization. I feel like I'm missing something key. Maybe this. No, I can Dijkstra this correctly. It's not that. I don't know. Maybe this. Okay. Okay. So maybe it is an integer overflow error. I think because it is specifically failing for this one where the number is really big. Wait, like 2 to the 31 minus that. It's still pretty big. Is it really a modulo error? Maybe this should be modulo. Nope. Let's just keep adding modulos until it's correct. Yeah, I just don't. It's like really close, except this thing's off. So I want to say it's the modulo thing, but maybe my DFS is just wrong. Ah. I really do not know where I could be going with this. The nitrous is correct. This is correct. So everything here is correct. Right? I notice your eyes are always clear to me. Makes no. Okay, that's. I don't. What the fuck, dude? 10 to the 9. Like 1, 2, 3, 4, 5, 6, 7. Did I not modulo it correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe there's no way that's the issue. Okay, well, it was an issue for that, I guess. Okay, 10 to the 9 plus 7 minus. Okay, so that's correct. What the Oh my god. Okay, maybe would this make it better? For some reason, this seems to be performing better than. I don't know the computer science behind that, but hey. This is also taking a bit. If I time a exceed. Okay. That's not. Oh, that's not. It's because that shouldn't be it. If this U is greater, is it greater than? Yeah, it is greater than. Alright. Maybe this needs to be. I'm already deleted though. Cool. A little closer, but still pretty bad. Also, test case, by the way. Dun, 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 dun. Dun, 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 dun. Turn DP in. This makes sense to me, so I don't know why it's not working. It's probably gonna break it, but I'm just trying whatever, dude. Oh. Oh, okay, okay. Oh my god. This is like a 1 hour video, I'm gonna be really sad. Shit. What could I possibly be doing wrong? Is it this? Wait, hold up, let me Dijkstra's algorithm. Wikipedia. Actually, wait, LeetCode, Dijkstra. Did I do this one? No. Okay, hold up. Graph. Network delay time. No, that's what I did. It's like bar for bar. Great. Okay. Maybe like that shouldn't matter though, should it? I guess it does. Oh my god. Okay. Dude. Oh, let's module that too, dude. What did I do? Why is it passing less? Okay, wait. Oh, okay. Oh my god. Turn 1. Dude. I'm like literally so close. Do I look at hints? So if U is unvisited, maybe it is the Where's that fill? dp with a -1. Oh. 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 That does make sense. Because then that'd really mess up the addition, huh? Okay, so let's just keep it at 0, huh? I feel like it just looks right to me, but I must be missing something really important. So if we already visited it, then we can return the pre-computed number of paths. And if this thing is this, we can say we found a path here. So for each adjacent node v, v, if the distance from the source is greater than this, then we can DFS. So dp of u is plus equal to the number of paths at v, right? Because from here to here, it's the number of ways to get here as well. That makes sense to me. I don't know if I'm doing something like blatantly wrong. 3, 2. Like, let's just remove the if statement. Oh, okay. That makes sense. Oh, because it would keep. Okay, this thing ensures that we don't go from here back and forth, back and forth. I might need to look at the hints because I don't know what I'm doing wrong. The only restricted path is 137. So starting from here, we want to go here to here. Because we can't do that. My god. Oh my god. Okay, I might just look at the hints. Okay, I did that. What? Okay. Discard this edge. Well, I did. I feel like I'm doing that. Okay. That didn't help at all. I might have to just stare at the screen for a bit. Am I just modulating too much? I don't think there's a way to module too much. Like, I mean... Cool. Yo. Okay, I feel like I don't need that one. I shouldn't need that one. If I need that one, there's probably something really wrong somewhere. Oh, okay. That's probably... Because if I submit this... See, that's the only one failing. So... Huh. Okay, maybe dp of u is module equal that, that, that. That way we don't need this one in theory. Great. This blows. It takes a while too. I'm gonna be really sad if I get a time limit exceeds turn 1. Like, do I need this? Guess not. I'm a fun man for the moon. So it's undershooting it, which means something. Like, should I just be doing this? Does this even give me a different answer? Surely makes it take longer. Okay. Turn 1. It would just be 0 though, wouldn't it? Right. Right. Because from here there's great. 1, yes, exactly 1 restricted path, and then from here there is 1, 2. So this is so 2 plus 1 is that. And this uses that, so it doesn't need to recompute. Dang gummit, dude. With a weight equal to weight of I. The way modulo is. Could it be that the distances are overflowing this, which means that I should be using long instead? There's no way that's the issue. Like, if that's actually the problem, I'm gonna lose it. Because now that I'm thinking about it, there's like a bunch of the path's distances would be really long, right? Cannot infer types. What the fuck are you talking about? Oh, okay. Yep, I'll just blow my head off, yo. Oh my god! If that's the... No, they wouldn't do that. Why would they do that? That's malarkey. From long to int. I'm sorry, I don't follow. Dist you. What is that? Awesome, dude. Just awesome. What do you want from me? Int cannot be converted to long. god. Oh my god. Oh my god. I'm a fat man, fat man. Compare Long's Java. Long.compare. Wait. A, B. Oh my god. No, so that wasn't even the issue. Okay. Okay, somehow that made it kind of run better, but. Dude. Oh, maybe this should be long? No, because it should be an integer. It should be an integer. Int. Like, I mean, what's the harm in trying? Well, that's true. No. No. No, it can't be. Damn it! Oh my god! Why? Dude! Awesome. My life is good. I love solving DP. DP is not bullshit. Okay, wait, what did that hint say about discarding? Is there anything I left in here that takes a lot of time? Nice, 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 nice. Discard this edge. What the f... What does that mean? What? So we have to only go in a decreasing order. Great. Okay, Fuck! Okay. Wait. What is... Ah! We're int I equal 1. I is less than equal to n. I plus plus. Int edge in adjacency I. Cool. If dist I is less than or equal to dist edge of 0. Okay, well, great. Can I, whatever, dude. Is that even allowed? Am I allowed to do that? Alright, awesome, dude. You said edge 0 is equal to 0. Some of that made it longer. But great. What does it mean discard? Discard that edge. What do you mean? What the removing elements from array list. I almost never do this, so cool. Cool. Equal 0 j is less than size j plus plus if adjacency of I get j 0. This is already looking really bad. Dist is greater than or equal to dist of I. Well, now I kind of want to use a hash map adjacency list. It's realistically not gonna. Nice. I'm gonna blow my fucking head off, dude. Discard. That is what they say, don't it? Cool, dude. Yeah, this fucking blows. We say adjacency I dot remove j. That's still 7 milliseconds, y'all. Okay, genuinely, what do you mean discard edges? Okay, maybe I should be discarding. Okay. So for an edge is equal to adjacency u dot get I, say, or int I equals 0. I is less than adjacency I. I not size I haha. So if this is true, then otherwise, if distance u is greater than distance, if distance u is less than or equal to, we'd want to remove it. So we'd say, I don't know, adjacency. Oh, do you want to move it both ways? Maybe that was the issue. Who cares? Adjacency u dot remove I u dot remove I. Great. What does it mean by discard edge? I can't tell if it's my casting. I don't think my casting should be making it this time complex. Okay, do I overhaul this and make the adjacency list a hash map? I think I have to. Like, okay, I might just read the solutions. Hold up. Okay. No. Maybe it was my casting. Okay, maybe. Great. So maybe instead it's a big integer. Let's just So just then that's a good point. Okay, I just got the same issue as before. What the hell's going on? Oh, maybe because of this? No. What the hell? Like, I feel like I solved it. I don't have a lot of experience with this like modules, like store handling big numbers thing. Extras, right? N equals 0. Gotcha. Use a min heap. Offer a min heap. Oh, min heap. Da, 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 da. Right. So for in edge and fuel. 0. So the weight. Okay. So if the distance to the 2 node is greater than okay, so our dexterous is the same, right? Okay. I mean, like, hello. think it's still... Does the distance also need to be an integer? Great. Great, dude. Interesting. Jesus. Okay. Is that like... I'm probably just gonna look like a dumbass now. What? What? Expected. Why would you expect that though? Why? Oh. Okay. I guess. I guess. If that... Okay. I, I literally, it's just the same thing except I did... This problem fucking sucks. Okay. So, rundown. We create our adjacency list. We keep a DP where DPI is the number of restricted paths from I to N. We use a distance so we could do this stuff, and then we just do a Dijkstra's. And then we just do a DFS, caching or memoizing how many... I don't know why. I need to read why this works. I'm not... Fuck this problem.